I'm going to take another attempt to record this video. I'm struggling with computer problems today. I guess we all have become familiar with during pandemic time. So this particular video is going to deal with how to find the equation of a regression line, how to predict y values using a regression equation, and I'm going to take that a step farther. We're going to do this with Statcrunch, where we don't actually have to plug anything into the equation. We're going to know when the regression equation is not appropriate for making predictions. You notice I've added a step to the Statcrunch instructions. Here in yellow, I put in a step 4, enter an x value for a predicted value of y, and I'm going to demonstrate that in a few minutes. We're going to use this feature of Statcrunch. It will provide y values for given x variables based on the regression equation. However, we should ask the question, when is the regression equation not appropriate for making predictions? One description of the cases where the regression equation is not appropriate for predictions is described in homework question number 10. And that question is, number 10, given a set of data and a corresponding regression line, describe all values of x that provide meaningful predictions for y. Prediction values are meaningful only for x values in or close to the range of the original data. We'll see what this looks like in just a second. We're actually going to see this we're going to apply this in question number 11. But this is sometimes referred to as being within the scope of the data. If I had heartbeat rates from a sample of adults aged 50 to 64, the regression equation obtained would be in no way meaningful to predict the heart rate of a 10-year-old child. It would be beyond the scope of the data. The second case where the regression equation would not be appropriate is when there is no linear correlation between two variables. This case will be addressed with an example from the notes in the next video. With this in mind, we will use Statcrunch to complete homework problem 11. The images are from the completed problem number 11, and the problem will be worked again in the review mode in my stat lab. So here is the question. Find the equation of the regression line for the given data. Then construct a scatter plot of the data and draw the regression line. The pair of variables have a significant correlation, and we're going to see that in just a moment. Then use the regression equation to predict the value of y for each of the given x values, if meaningful. The table below shows the heights in feet and the number of stories of 6 notable buildings in a city. And notice we have 4 numbers there. We have an x of 503 feet, an x of 645 feet, an x of 798 feet, and an x of 733 feet. Now, the regression equation we have here is what we're going to produce with Statcrunch in just a second, but we need to note the table. The range of x values is from 480, there's our lowest, to 762, our highest. And that range is going to be important as we make predictions using this regression equation. Now, at this point, I'm going to have to choose a graph and the 4 values, but at this point, let's go ahead and return to the problem itself. And you see I have the problem here. This is from my own assignment that I worked. So I know I can click the icon and open this data in Statcrunch. And the data is there open for me. Now, what do I want to do with this? I want to go to Stat, Regression, Simple Linear. Now, you notice that first number is 503. I'm going to use that here. So when I go Simple Linear, I know my x variables are the height in feet, the y variables, the number of stories. Now, here's the thing. See down here where it says prediction of y? What I want to do with that is I'm going to put that 503 right here. Now, they don't give us an alpha in this, and you can use the default. The default is 0.95. And that would anytime a significance level is not given, 0.95, or confidence level, 0.95. Now, notice my hypothesis tests, I don't have to touch them. I have H naught of equals 0, and then the intercept of not equal to 0. So that's a default. That's going to happen every single time. So when I click compute, here's what I get. First, look at this line right here. I think I can highlight it where it says stories, comma, y equals 16.591,798 plus 0.046327868 height, which is my x value. Now notice this would, instead of y equals mx plus b, what have they given us? They've given us y equals b plus mx. They've just reversed the order. So I can see this is my slope right here, this number that's with the height, and my intercept is right here because I notice there's no variable with this 16.591. Now, we rounded that, and when we round that, I think we had the, let's see if I can get back to it. There is 0.046 plus 16.59. Let's pull Statcrunch back up. Whoops, wrong one. And we notice that 16.59 is my intercept, and 0.046 rounded to 3 places is indeed the essentially the slope. And you notice that it's both filled in right there. So I've got my regression equation. Now let's just look at the p-value. And what we see is a p-value of 0.0173 right here. Right there, I know that's less than the significance level of 0.05. Remember, that's our default when not given. So I know that I am going to reject the null hypothesis. And when I reject the null hypothesis, what am I rejecting? I'm rejecting the idea that there is no linear correlation. I'm accepting which provides support for the claim that there is some significant, or there is some linear correlation. We don't know whether it's weak or strong yet, but we know we have it. We see our correlation coefficient right here is 0.89, 0.9. So that would indicate that also that if we were using a test statistic method, we have linear correlation. So since we have linear correlation, this makes this regression equation appropriate for making predictions for most of these values. Now, let's look at down here then. Now I know that I can use this. Well, when x is 503, y is 39.89, which rounds to 40. And there's the answer for A right there. Well, now they want me to do 645. All I have to do is click this options button, edit. I don't need to change anything up there. I'm just going to change this 645, from 503 to 645. And I'm going to click compute. And again, I'll scroll down. And now I have 46.4, which is, now remember, we can't have part of a story, can we? So, and then on the next one, we got a slight issue. No, actually, the fourth one. The next one is 798. And 798, we already showed previously, is outside the scope or the range of the data. So that would mean that this would be not meaningful. There's no point in making a prediction with 798. It's outside the range of the data. And then our last one is 733. That is inside the range of the data. And I'm going to I'm going to edit. I'm going to come back down, change that 645 to 733. And there's a minor discrepancy in rounding on this one, which we have whenever you, we've talked about this before, a little bit less precise, whereas when we use Statcrunch, we're much more precise. But anyway, we get 50 point, when I scroll down, I get 50.5. Well, from my answer choices, I can clearly see that was meant to be 50, even though it's just, you could argue that this would round to 51, but for what we have here, this is the answer that is acceptable. So you've seen how to find your regression line, how to use it to make predictions. The last video we're going to look at is what to do to make a prediction when we have a set of paired data, but the two variables are not correlated. And we're going to use an example from the notes for that. So I hope you find this helpful. Hopefully it will load the way it's supposed to this time. And I will have one more video for you shortly.